Hello. Our group did a project on carbon sequestration. This is a major problem in the United States. In the United States, it's estimated that over 6,870 million metric tons of CO2 are emitted a year. This affects the carbon cycle negatively because it creates way more carbon than our forests and carbon dumps are able to handle. Companies have come up with methods to reduce carbon exhaust, so it's not necessarily necessary to engineer a new method. Our goal in this project was to find the most efficient current method to remove carbon from exhaust. This was picked as our goal because there are already many methods of carbon sequestration. We just needed to find the most efficient method. Our dataset was selected from the carbon sequestration dataset. To make the dataset, a company had to include both power usage, type of removal, cost, and as much as it processed. Now there was a problem when it comes to as much carbon as was processed by the unit. The problem was some only labeled in percentages and not into tons, so there was actually two data sets that we've created here. We have the one on the right, which is tons per day, and on the left, percentage points per day, as this would be 90% per day, 85% per day, 65% of all the CO2 in a plant used per day. And this metric here is the cost, this is the method, and then this would be the amount of power usage. Same goes for this data set. Okay, the metric that we used in MATLAB was to find the total efficiency. We took the carbon captured, divided it by the cost times the energy usage plus cost. Now you say this extra cost might not be necessary. We included the extra cost to eliminate zero energy values messing up our data or creating a divide by zero error. So the cost was added. The greater the TE you have, the more efficient method it is. Alright, so our algorithm starts here. It starts here. We have a CLC, a clear, and a close all as housekeeping commands to eliminate any stored variables and close any windows, delete variables, clear the workspace so it comes out nice. Now, we used XLSRead to remove our first data set from Excel. And what we did was, said, alright, we took that, then we went down to text, and we said, we'll take the text and transpose it, that'll be used later. Then we took column 4, which is the carbon conserved, or the carbon taken by each unit. This cost variable is in the third column of num. This is going to be how much it costs to build the unit. Energy usage is the first column in the data set, and that is going to be how much energy each unit used per day. Now, take this down. We have total efficiency equals the dot dividend of cost times energy usage plus cost again to eliminate those zero values. Can't have those divide by zero values. So then we have our output, which is going to be the maximum of our total efficiency. The max total efficiency is max TE. This TE is just going to be a list of numbers, however many data points long, on the total efficiency. And what this is going to do is this is going to take the maximum value of all those values. Now what this is going to do is this is going to take the find. This is going to go through and find where TE is equal to the maximum value. So this is going to be like your y coordinate, your xy pair. This is going to be the other value. This is going to be where TE is equal to this. So we're going to take that and we're going to use the z value. We're going to set text equal to that. Now this is why we transposed our text command, so we'd have a nice 42 by 1 row of everything. So we could take the value where this is equal to this, and then we can plug it into here and have it display the most efficient method. Now we're going to run this section and see how this works here. As you see, Exxon controlled freeze zone is the most efficient method as determined by our program. Now, the same thing goes for the second data set. Since we could not compare the two data sets, what we have is the same thing, only this time we're going to import the carbon data converted as a percentage. That is right here. Now it's going to do the same exact thing and output the same exact way. Now, that's our algorithm. The code capabilities are pretty much anything with total efficiency where you have a cost, an energy usage, and amount of something processed. This is going to be very useful for anything. The way we set this up, all you would have to do to import new data would be to take you'd have to set it up in the same manner. You'd still have to have energy usage, method, cost, and then percentage usage, or in the case of the first data set, amount processed. However, it doesn't matter how you represent those values. As long as they're in a common currency and use common units, this should give you an efficiency number and find the most efficient method of whatever thing you have, no matter how many data points you have. As long as it's set up in this format, it should work for basically anything. Now, that's the capabilities of our code. Now, the limitations and applications of this code. The limitations of this code are basically you're going to only have 3 compared metrics, and one has to be a unit of processing, something you processed. You're going to have a cost value, and you're going to have an energy value. Not necessarily an energy value, however, it could be any metric really. However, you can only have 3 metrics of determination to figure out which one is the most efficient, where you have things that eat cost on the bottom and things that are good, which you're trying to accomplish, on the top. That is the capabilities of our code.